time we should be. Hello.
Hi everyone, good morning. Am I audible?
Good morning, ma'am. We are waiting you since last 20 minutes.
Oh, I'm sorry, really sorry. So the class should start at 7 to 7, 5, 10. Yeah, so we will have we'll start the class from next weekend onwards. So let's talk about the timing, right? Because it is a weekend, I just want to ask everyone um, if 7 is okay or we will start from 7:30 to 10, which will be good.
Ma'am, can I interrupt you, ma'am, for a second?
Yeah.
Ma'am, actually, I supposed to attend the class from Dubai.
Oh, okay.
Okay. And my that as far as weekend is concerned, Friday is a week that off.
Mhm.
Saturday, Sunday is working for me, and this working here is start basically nearby. What you say? 6 a.m. early in the morning.
Oh.
Okay. So it will basically, in fact, I would love to basically if you can shift that time too early rather than shifting towards other side.
Okay, fine. No problem. Understood. So I
So
think
maybe
if
you
you
can
want
start with
to,
the
no,
6
no,
to 8
will
30.
be 6 will be very early for everyone who are in India because it's a weekend, right? People will not be interested to wake up at 6 o'clock. So I think let's fix
Uh,
the same timing, 7 to 9:30.
Ma'am,
Because I
evening
feel
is not
like
possible. Ma'am, you are not conducting any batch in evening.
no. Evening, I think most people will be out of like home, right? It's a weekend. So let's fix the same timing,
Actually,
7
ma'am,
to
problem is
9.
what? Very honestly, ma'am, very honestly, sorry, ma'am, for disturbing you. Seven.
I'm Yeah, I'm planning to prepare new notes for your batch onwards. Today I will be using my old notes, but next time when you connect, I'll be creating a very nice note for you. Everything in one, using this one note, everything in one I will summarize so that you will, at least the theory part will be. So what is my aim, right? My aim is whatever I'm covering, you should not spend time going through the same topic again from anywhere. Once it is done, it is done. So for example, if I'm explaining you, let's say GAN network, right? Um, then in GAN network, whatever I'm talking here and whatever examples I'm giving and all the theory, it is completed means completed. You should only practice. You should not go again through the theory chapters, right? From other sources. And that is the goal. So I will be teaching you end to end. And the deep learning will take 2 to 3 weekends, almost like let's say 20 to 25 days to 1 month. And that is very specific to generative AI. It's not like complete deep learning. Complete deep learning, if you want to learn, it will take like 4 to 5 months, right? But we are not interested in that. So generative AI is a subsection. Today, I will first talk about the sections that we have, right? Let me share my screen. Okay. So I'll first show you, I think you have seen this diagram very often. Many times you have seen it, but I think I just will love to show you again, right? Where is that? Okay, let me write it down, right? As I said, I'll be sharing with you nice notes from next weekend onwards. But today I will just prepare you for the course, okay? So before we start, what is deep learning? Many things will come in your mind, like what is artificial intelligence, what is machine learning, what is deep learning, and what is neural network. So the hierarchy is, I think in the demo sessions I have already told you, but I will show you the charts also. But if I just tell about the entire thing, everything that, so like everything is falls inside artificial intelligence. So artificial intelligence is the top level, right? Actually, artificial, there is no subject called AI, okay? there is no particular concept or math model or algorithm called AI. AI is just a very, very, very vast superset, you can say. And the objective of AI is artificial intelligence is how we are thinking, right? If we can understand our own process and can give that intelligence to the machine so that the machine can mimic human. That is the objective. So when we reach, so like you have seen the journey, right? First it is AI and now we are moving towards AGI, artificial general intelligence. Means what? Yes, like we are also machines in a way, right? If you think about it. And we are processing a lot of things. We are taking input from different organs, like from ears, we are listening. So this is speech data, right? We are writing and we are watching. So that is a image data. And then we are reading. So this is, let's say, text data we are reading. So image data again. So image, text, and then your audio, everything our brain is processing, understanding, and we are doing some action, right? So can we give that intelligence to the machine? That is whole story about AI. And we will think, I think we will reach to the highest level of maturity the AI machines will reach when they are equivalent to human, right? That's the objective. That's the goal. But now how? This is just a theory, but how? There are certain subjects which we need to learn so that we can give the intelligence to the machine. Behind the scene, if you ask me, these are nothing but maths. So if your kids are there and they're in schools and something, if you want to teach some subjects, I think maths and related subjects, right? Maths related subjects like physics and all. So those are the backbone of artificial intelligence. This Python, Java, or other programming languages, TensorFlow, sklearn, these are just the wrapper. So if you don't have those, you have to write it from scratch. Like how to implement, that is just a wrapper which will help you to write the algorithms in an easy manner. But behind the scene, if you just go deep into it, all the AI, entire AI is all about maths, nothing much. So starting with simple maths, like school level maths, like set and like matrix multiplications, from there to BSc advanced level maths. If someone is BSc or MSc mathematics, if I teach them any algorithm from this machine learning or deep learning section, they will be telling, oh, this I know, oh, that I know, oh, this I have studied, that I know. Because when I was going with this masters and if you join any MTech, that's the reason when you join any MTech or PhD course, or in fact, in nowadays BTech also, initial 2-3 semesters, or maybe first and second semester, they will teach you maths and maths and complete derivatives. So you will be like thinking what I'm learning and why I am learning. But later you will able to relate, right? They will teach you linear transformation. If a object is like the n dimension, how to reduce it to n-1 dimensions. What is latent space? What is linear transformation? What is linear programming? All of these concepts you need to learn. I'm not scaring you. This is the whole story, but we are not covering the whole story, and that is not needed. The structure of this artificial intelligence, right? Or basically the structure of, sorry, this 1 second. I'll be moving to my iPad next weekend. This time there was no charge. In the morning, I realized I put it on the charge, but it was not on. So today morning, I realized that. Anyway, so the sequence of artificial, everything is AI that you understood. Now we have subjects. And one of the subject inside AI, I can say, is machine learning. And the first, I will show you a chart. When like in 1900 or like 1900, initial days of 1900, people thought of rule-based creating simple algorithms, and we call it machine learning. Slowly, so they added little more complex and complex maths, and that gave them different algorithms. So machine learning is a kind of subject within artificial intelligence, and within machine learning we have a sub branch. We call it, so I can say this is machine learning, which is a subset. And not only machine learning, like this, there are a lot of other subjects inside machine learning. To solve a particular section, we can also have something called deep learning. Okay, we call it neural network. So neural network are the subset of machine learning. And inside neural network, maybe we have another subset. We call it deep learning. Okay. So inside this, we have deep learning. And inside deep learning, we have a subset called generative models. Right. So here we are. I think you can understand. So if you want to go from down to top, so whatever we are learning, GAN networks and all, generative model are a part of deep learning. This deep learning is a part of neural network. This neural network is a part of machine learning. And this machine learning is a part of artificial intelligence. Or artificial intelligence has a lot of subjects. One of the subject is machine learning. Inside machine learning, we have another subject called neural network. Inside neural network, we have another subject called deep learning. Inside deep learning, we have a subject called generative models. And deep learning is not all about generative models. Deep learning has many other algorithms. Similarly, neural network is not all about deep learning. It has many other different kind of neural networks. So I think you understood the hierarchy. Now I think at least when you heard that this term, you should not be confused. Deep learning means it is a part of neural network. Neural network means it's a part of machine learning. Machine learning means it is AI. So basically when you are learning AI, right? AI, you have heard this term. You are learning F. So I remember I told you tomorrow the T structure. You cannot, I think this is dangerous if you just know everything. Let's say a few things you know from machine learning, few things you know from deep learning, few things from neural network, few things from generative AI, but you're not expert in anything. You just know very superficial or very high level, surface level things. This is T structure. You know everything, but you are not expert in anything. Now, what is this structure? This structure is you don't know anything about machine learning. You don't know anything about neural network. You don't know anything about deep learning. Directly, you jumped into generative models, which 90% of the people they do, right? And they think, okay, let me start my journey from generative model. And they just try to become expert in, and I'm not telling only prompt engineering. They have learned the concepts and then they have jumped into that. So that is this structure. So what is this structure? This structure means you are good or expert at generative models, or you are expert in deep learning, or you're expert in neural network, or you're expert in machine learning, let's say. But you just know this, right? For example, an ML ops engineer, he is very good at ML, machine learning, but he doesn't have much knowledge in neural network. That doesn't mean he completely can say, I don't know. That is not correct. You should know, and then you should select one domain. You can select many domain. It's a vast, it's an ocean. You cannot become expert in everything. That is literally impossible. You are human. So you can take either text like NLP and become an expert. You can take image like computer vision, and then you can become expert in that. Let's say you don't want to come to unstructured, become expert in machine learning and learn the deployment side. That is also very good, like ML ops. So you take any one domain and become expert in that. And that is the correct way. Okay, what you understood from all of this, I think there are many diagrams. I have just downloaded some diagrams from internet. This is the neural network diagram. I'll explain it later in the next class. As I said, I will prepare a very good note for you next time when you connect, right? So this is some brief history about AI. I think many things, as I said, everything started with math. So in 1940, and this is I will say this is this person, Rosenblatt, right? Rosenblatt. This person is the main person, like who has developed the basic neural network architecture, the very, very fundamental single layer neural network. In 1950s, neural networks are not new, right? Many people think, okay, this ChatGPT came in 2000 and all. No, it was like 1950, the starting neural network that has been created. If you look at this type, like this diagram, you will understand it is somewhere around 1950, this era, right? This is the time, right? And you can see this is perceptron, and this is the person. Remember, later I will explain. And this is the architecture he has proposed. And then you can ask me one question: what happened like 1950 till 2020? Like it's like 50 years. What happened? Why I am not hearing a lot of things with respect to deep learning? Like it started 1950, but so there were some very, very big problems in deep learning section, which has been addressed around 2009. So you can see this is a golden age. They say golden age, or basically in this window, I will say rather than this, I will say somewhere around 2008 or 9, 2000, this is not written, but 2007 to 2010. Actually, this is the golden age. And then, yes, this is like the diamond age we are in now. But what really happened, like after 2007, if you just look at the trend, Google trend, and search the term neural networks, you will see after 2009, there is an exponential growth in the search term, because the problem that we are suffering for last 50 years has been addressed in 2007 to 10. What is that problem? The problem is this neural network behind the scene, it is nothing but, if you just go deeper and understand every tit by tit, it is nothing but matrix multiplication. We will understand in detail in the next class. It will take 2.5 hours to make you understand the architecture. But what I'm saying is it's just matrix multiplication and derivatives. Derivatives are nothing but, if you just open all the derivatives, you are multiplying, right? Chain rule, so you are multiplying. So derivation or like derivatives, and if you just look at very ground level, it is nothing but matrix multiplication. And there was a problem when you multiply a smaller number with another smaller number, it will become even more smaller number. So you're not understanding anything, I know, but what I'm trying to tell you is there was a problem called vanishing gradient descent. What is that? We will understand in the next class. But because of that, right, because of that problem, neural network, we were not able to train. The training of neural network was not possible because of certain problems exist. And in 2007 to 10, and in fact, after 2007 onwards, there were a lot of techniques which has been invented, and those techniques using that, right, one of that is backpropagation, some not backpropagation, activation function, and then lot many other we will discuss in the theory class. But after all of those techniques has been invented, the problem is solved. Now we can train our neural network, and from there new research and innovation happened. Now there is one more thing. I think this chart you can see here, this is the diamond age. Now, what is the diamond age? Diamond age is somewhere around, let me erase everything, 2017. I just want everyone to just look at this, right? This time, 2017.
Your screen is only that visible. Deep learning, machine learning, circle only.
Is it? I'm showing since then. Oh, sorry, I was showing this. You're not able to see this? Now you can see?
Now we can see, yeah.
Oh, sorry. I was yeah. If some problem like this happen, you please unmute and speak. Okay. So I was talking about the history, and this is sometime important to know what happened in the history, right, of AI, the entire history of AI. So people think neural network and deep learning are very new concept. No, it is not new. It is actually started in 1950. That's what I'm showing. This person, Rosenwald, please remember her, remember him. We will revisit this, right, in the next class. So this is called perceptron model. What model he has created. This is the basic neural network. This is the starting point, you can say. And before that also, it is XOR. From the XOR concept, the XOR gates, the perceptron architecture has been created. So this is the starting point. And what I was talking here is we have you heard anything about deep learning before 2009 or 10? No. Like I like after 2000 or 2005, 6, there is a tremendous growth in deep learning. So what I was explaining is what really happened. Like it started around 1950, but like 2000 and 2010, like 50 years, why nothing happened? Like why deep learning was not popular? Why people were not using it? Because training of deep learning model was not possible because of a concept called vanishing gradient descent. We will understand what is that concept. There was a problem. In very simple term, there was a problem which could not be addressed. And that's the reason we were not able to train our models using deep learning. But it has been addressed in 2010. And the moment we found the solution, you see the growth, right? It is just about 14 years. And we are already in AGI, right? Or we are moving towards that. So in 14 years, 2010 to 2024, right? It's just 14 years, and like we are just going. We're moving forward. There is no backward, right? It's just forward. And again, there is a revolution happened in 2017 by Google. And this revolution is by Google. People give all credits to OpenAI and GPT. Do you know what is the backbone of GPT? It's Transformer. And actually, I think like most of the credit should go to Google, because they are like the paper that they have released in 2017 called Attention All You Need. I will take you through this paper at very high level and make you understand the Transformer architecture in next weekend. Attention All You Need. This paper is released on 2016. And this is again a groundbreaking research. What this paper addressed is long context memory you can save in neural network. The problem is when you are solving this kind of word generation or prediction problem, you need to understand the context. Context means not only the before word, like lot many things you need to remember. What has happened before sentence, before to before sentence, before to. So that is called long context window, right? And that was the problem of any neural network. Cannot remember very long context. But because of this transformer architecture, any transformer, the main architecture is attention. The main architecture is attention. And because of that, right, people understood how neural network can save or can understand long context. And that is a groundbreaking research. And again, you see after this research, just we are in like 2017 to 2014, just around 7 years, 7 to 8 years. And again, we have seen GPT 1, 2, 3, 4, and so on, right? And it will continue. Maybe I don't know what will happen. If somebody else is kind of solving some more, now we are hallucination is a problem. And maybe somebody has solved, maybe we will able to get some more intelligent systems. So this is the whole journey. So what you should take away from this chart, you should remember the actual thing started in 1950. It took almost 50 years to solve a simple problem in, not simple, sorry, mistakenly I told you, but it's a big problem actually. To solve the problem of neural network called vanishing gradient problem, which has been addressed in 2017, sorry, 7 to 10. During that time, a lot of innovation happened and that has been solved. After that, people started working on deep learning. They started using deep learning. And in 2017, Transformer came into picture. It is given by Google by a paper called Attention All You Need. In Transformer, there is a new mechanism that is called attention has been added. And why it is so important? Attention gives neural network the strength of remembering long context window or long context it can remember because of this architecture. And after that, there is no going backward. It is just forward. Every year you can see GPT-1, GPT-2, GPT-3. You heard about GPT in 2022 called ChatGPT. That is actually like GPT-3 and onwards. Prior to that, there were a lot of other models. 2019, GPT-1, GPT-2, and then GPT-3 came. So GPT-3 and GPT-4 were like kind of groundbreaking because it is huge, it is massive. And let me tell you, the neural network or the algorithms are the algorithms. Like why anybody till today, they're not able to beat this GPT and other architectures. Data also plays a very important role. One is maths and one is data, because the maths, if you are running the maths in a particular kind of data, which is garbage, but I am running the same math in a data set, which is very good or quality data, which has pattern. So my model will be good as compared to yours because you have put garbage and the model could not understand anything, but my data is very good and the model understood all the patterns. So what I'm trying to tell you is, yes, algorithm, maths, everything is important, but more than algorithm, data is important. In any AI system, to find pattern, your input should have pattern. So quality data is very important. This is the whole story. What you need to remember, now what happened to 1950 to 2010? I will say this is the where people also started a lot of algorithms in machine learning because deep learning was not working. They started creating a lot of algorithms in machine learning, and till today also machine learning we use. In fact, it's not fancy, but 80% of the problem, I don't know what will happen in future, but today if you ask me, 60 to 70% to 80% of the problem we can solve only using ML. We don't need deep learning. But the 20% of the problem that we have cannot be solved at all using machine learning. It has to be deep learning. Mostly if your data is text data, image data and all. And they say this era, this deep learning will be so much in demand because 80% of the data is also unstructured. If you just think about it, gather all the data that is available in internet, you will see 80% of them are unstructured data, like some form of video, like YouTube videos or text. Very, very limited amount of data you will find in the tabular format or structured format. So they say that is the reason deep learning is so popular. And it will be more popular because to solve this 80% of the data, you need deep learning. So I think this is the whole story. I think you are clear. So what you understood is there are certain things happening. So we are just using the tools. We don't know what is happening behind the scenes. It's a lot of research, lot of hard work by a lot of scientists. And remember this person's face. You can see in every era, this person is present. This person is known as the guru of deep learning or father of deep learning, Hinton. He is now in Google. But yes, this person you can see in every year. And why I'm saying this person is so important, he has a great role solving the problem that I was talking, that we were struggling for last 50 years. He has given a lot of solution for vanishing gradient descent problem. And you can see this is the era like 2010. So this is the time where actually we found the solution. Okay. And you can see this person like starting with 1980, he is there till today. So last 30, 40 years, he is like a guru, right? Lot of research happened under him, right? I think he was in Stanford and then now he is the chief of Google DeepMind or something, right? Okay, any doubt in this? It's just a theory. You need to remember.
Ma'am, so ChatGPT is based out of deep learning.
Yes, so that's what I'm saying, right? So you can see ChatGPT is based on this transformer. We will discuss this. So this is called the transformer. In the syllabus, if you check transformer, we will learn. So what is transformer? It is a deep learning model. So this is, are you getting? So we have many deep learning architecture. I just skipped all of them, but we are in 2017. Transformer architecture is the game changer, right? So it's basically a deep learning model, which is based on encoder and decoder format. I'll talk about it. I don't want to tell you jargons today. Just remember the history. We will understand everything one by one. We will start from here. So back propagation. So we will start the basic algorithm today, like called, actually we will start from here. Okay. So here we will start today. Perceptron. Remember this happened in 1950. This is the basic architecture or first neural network, you can say, of single layer, which is called perceptron. Today we will understand this perceptron. In the next weekend when you join, we will understand this one. Right? Let me erase everything. So today we will learn this. This is the first architecture, and then we will learn the complete neural network, fully connected neural network in the next weekend. And then next to next weekend, or maybe next weekend, Saturday, we will learn this. And Sunday, we will learn this. Or next to next weekend, we will learn this. So there are 3 different steps we need to learn one by one, starting from basic till transformer. And if you know this, see, if you understand this transformer architecture, theory plus implementation using PyTorch, you can create your own GPTs. Because you know the theory, you know the libraries that will help you to create. You can create your own GPTs. It might not be so powerful because so once you know the architecture is just like you make it super complex. Super complex means you just need to increase your GPUs and computing power. But in fact, if you don't have that also, with simple, like you can build simple GPTs from scratch, your own GPT in your own data, in your own laptop, you can create after you understand transformer end to end and you know how to implement it using TensorFlow or PyTorch, you can create your own GPTs. And that's how we have 10 lakh models. 10 lakh models in Hugging Face. Last time when I was taking batches, it was 7 lakh. Now in this 2-3 months duration, another 3 lakhs has been added. So you just heard about one or two tools called ChatGPT. Behind the scene is GPT-4. And then you heard about Gemini maybe, right? And you heard about Claude. Maybe you have heard about this 3 or maybe Llama. This 3-4 you have heard about. But there are 10 lakh such LLM and foundation models available, free of cost, open source. Now you think like if it is so difficult, people cannot create 10 lakh models, right? So you can also be one of them and you can also contribute. It will become 10 lakhs one if you contribute your own model, right? And it's not difficult. Once you know the deep learning things and you can build it from scratch, right? You just need to understand the things. That's it. And that's the reason it is very important, right? To start from scratch.
I guess,
Okay.
ma'am, your voice is breaking.
Is it? My voice is breaking. Others, can you confirm?
No, ma'am, it is
No,
clear.
no, it's so clear only, no problem.
So
So,
maybe
madam,
at my end. Sorry.
Yeah.
madam, hello, madam,
Yes.
I want to know, do you need to means we need to learn Python for this course, right? Or how to program all the modules?
Python, see, there is a different kind of Python. Let me show you some of the code that will give you some confidence because I'm getting this question a lot of time. I will explain this. See, yes, Python is needed, but what I'm saying is core Python is sufficient. Other
Okay.
Python, whenever you have time, you can learn because this course has its own libraries and that you will learn. For example,
Okay.
let's say this is one of the LangChain, let's say document loading. And you can understand this is also Python, but do you think this is any like web development Python? No, this is very specific to OpenAI format or
Right.
lang format Python. So this is the way you need to write your code. And I think this kind of things we will do a lot. When you use PyTorch or TensorFlow or create deep learning models, you have to use deep learning based architecture. For example, let me show you some example, right? And you will see the difference, what I'm saying here. Let's say this is, I don't know, where is it? A lot of, let's say, linear regression, let's say, right? Okay. So this is linear regression with Keras or basically ANN architecture. So this is also Python. But see, what we are using is all libraries we are using. TensorFlow, Keras, PyTorch. And this is, see, this code is nowhere related to anything in Python, right? This is a completely different deep learning code. So what I'm trying to tell you is, yes, Python is necessary, but every framework has its own type of coding and which you need to learn. You need to learn libraries, basically, different libraries, 8 to 10 libraries you will learn. Like LangChain is not a library, but it's a kind of framework that has a different kind of programming. OpenAI, when you use, it has its own kind of way of programming. TensorFlow, PyTorch, yes, it has its own kind of programming. Like this is Keras, you will be using Keras. But basic Python, let's say I have loading the data. So this is pandas, right? So what you really need is, if you ask me, let me write down. This is very important because if you don't have that knowledge when you connect next class, at least you should learn this much. Please note it down. If you don't have Python knowledge, I think this much you should learn. The first thing that you should learn is how to declare a variable in Python. I know this is very silly, but yes, it is important. And then the function concept, how to create a function and how to call a function. And then you need to learn something called loops, like if and then else loop and for loop and while loop. And then if you have some time, you learn the data structure concept. One of the very important thing is pandas, at least at high level, like how to load data frames, because a lot of the times I will be reading files. Pandas, I don't need everything, but just very high level, just you take my recordings and learn pandas from that, right? Honestly, you don't need all the pandas, just learn the input output, how to read any document into pandas data frame. Or basically, I will explain you when you connect next class. I will explain you when I'm coding. I'll explain you the pandas code in detail, right? And that's it. I think basics about dictionary and list and string maybe, right? And tuple is not needed, but if you want. So this is what you need to know. And if you are really interested and you want to like have time, this is mandatory. This much you should know at least. And yes, one more is NumPy. And don't worry if you don't know NumPy, we are not going to use NumPy anywhere because we have advanced. NumPy is the ground level library, which we really don't need. We have advanced libraries like TensorFlow and Keras, and NumPy is not needed. That's the reason. But pandas and dictionary, this is what I am expecting you to know. Other things like what is a module, what is a class, what is a package, library, module, package, and all that. If you have some time, you can go through. Otherwise, you will still understand everything. Can skip.
Matplotlib also very old. Matplotlib.
Visualization, yes, matplotlib or plotly, but that is not needed. Deep learning, we cannot visualize anything.
Okay.
Right? Deep learning is black box. So deep learning is, and we don't care about the dashboard creation or feature selection or something. So I think deep learning is more than sufficient. It will take care of feature selection, outliers. Directly, it is actually easy. Machine learning, you have to do a lot of things. In deep learning, just give your data as it is. After you convert it into numbers, everything will be taken care. So it is so powerful, it will take care of everything. Like what I'm trying to tell you, you will not understand, but a lot of machine learning steps you can ignore in deep learning, right? So for that reason, and it is black box, you really cannot see what is happening behind the scenes. So visualization, if you have some knowledge, that is good actually, but it is not mandatory. It is not that important, right? So, Plotly or Matplotlib, you can learn. And this all things has been covered in the MLOps class, right? But if you don't have that, basically you can just go through some basics. That's it. And honestly speaking, if you don't know anything from this also, 95% of the code you can still understand with this. But the last point will give you confidence, right? What I'm saying is sometimes if you have to create some charts and if you know Plotly, that is helpful. And charts, we really don't care. You create it from Excel or Plotly or Power BI or Tableau, who cares? Until unless the chart looks good and interactive, right? So that is different thing. And charts, this is not a visualization course. Very rarely I will use chart, right? I think it's not there.
Ma'am, sorry to interrupt you, ma'am.
Yeah.
This side DP Sharma. Actually, I have to leave from my office as I discussed with you. So maybe I am basically first of all sorry I am disturbing your flow. I have one question only. As per I have gone through the syllabus and I found that one topic is Open Azure API, right? Azure API you are covering through this
Mm.
Microsoft Cloud, right?
Yes.
So I'm just wondering one thing. As far as I know, the Microsoft policy, individual accounts they are not giving this access. They are giving access on individual account based upon some organization behalf, right?
Mm.
So how basically we are going to that have the lab session on that
I'll
technology then?
explain in the class. I will explain you, right? In the class, I will explain you. If I start telling, it will divert the topic. So it is
No, no,
possible.
just basically I wanted to know just whether they have changed the policy. The access will be given to us, na?
Yes, yes. Why
How?
not? You can
Okay,
have your account, no problem.
okay.
Yeah. And in fact, you can just, I will just show you Azure OpenAI, but in fact, you can just have your own OpenAI API key and you can use frameworks like LangChain and all, and you can do all the development.
No, no.
Right?
See, ma'am, Open API individually with LangChain is different thing. I'm talking about Azure
I
basically.
understand, Deepak, and I'm saying yes, and how to do it, I will explain in the course. When you join that particular module, right? When we go,
Okay.
I will tell you. Okay, it is very much possible. I'll explain. I'll show you actually, right? In Azure, how to do it, and in Gemini, how to do it. I'll show you how to create
Okay.
your.
So you will so ma'am that your the DurgaSoft will provide the account or how it will work?
No, no, you will have your own account. I'll show in my account. So everybody will have their own account. Why DurgaSoft will provide.
Okay.
You have to
Okay.
have your own account, cloud account, right?
Okay.
You have
Thank you,
you
ma'am.
have to
Thank you. Thank
register
you.
with your email ID and your phone number, your credit card information. But I think Azure, if you have already used, you can just see what I'm doing and you can skip and just use OpenAI API key.
Ma'am,
That's
I
much
have
cheaper.
tried. I have tried. Ma'am, I have tried everything. Azure Studio is possible. Azure OpenAI Studio, they are not giving access until unless you are registering on behalf of the organization. Individual, let's say my Gmail account is there, they will not give the access.
I will explain you. You need Microsoft. I will explain it. Okay, in the module, I will tell you.
Okay, okay. Okay, ma'am. Thank you. Thank you. Ma'am, sorry, I'm leaving now, ma'am.
No problem. Yeah.
Okay,
And
thank you.
Sasmitha, you said in 2010 the problem that was resolved was vanishing gradient descent, and this vanishing gradient descent is very similar to the gradient descent problem that we have discussed in machine learning.
Yes, exactly. Same problem.
Okay. That means they were not able to meet the global minima to reduce errors.
No, actually, what was I don't want to explain because in the next class, if I explain, everybody will understand. So
Okay.
the problem is, I can give you just in 1 minute. The problem is this. So let's say I'll just, everyone you can understand, it's not a very big thing, right? Let's say y equals to 3x and let's say, okay, in this way, right? So dy by dz is equals to, let's say y is a function of x and x is a function of z. Let's say 3z or something, right? Like this, right? So if I write dy by dz, can you tell how I will proceed? So you remember chain rule. So y is a function of x and x is a function of z. So can I write dy by dz is dy by dx and dx by dz? Is it possible? Sorry, dx by dz. Yes or no, everyone? Please say. Dy by dz is dy by dx and dx by dz because y is a function of x and x is a function of z. I'll just pause here. Is it clear, everyone? Clear, right?
Dx was cancelled, so it's dy by dx.
Sorry.
Dx numerator and denominator dx by dx will cancel, right? And then dy by
No, this
dx is
is
the
with
equation.
respect to, okay. So, okay, like y is a function of x. That's why I'm not explaining now. You will be a little confused. Let us understand the derivative concept first, and then you will understand, right? I'll explain from scratch. Maybe today I will explain first derivative and then we'll come here. So the problem is like this, you will have lot of matrix multiplication in your neural network. So when you find derivative, the last layer is the function of next to last layer, next to last layer is a function of, sorry, first layer is a function of next, like second layer is a, from backward you will see. I need a chart to explain you. So when you just calculate the derivatives at the first layer, actually it is a function of all the before layers from the end layer to the second most layer. So it's basically matrix multiplication. And the problem is when you multiply, let's say this value is somewhere around 0.01 and this value is somewhere around 0.1 and you multiply, it will become 0.001. And so the values will become so less, the model will actually stop there. It will not train further. So it's very slow. So there is a problem called gradient descent. I think this is not the right time to explain you this because you don't know anything about like the entire concept. So when you next class you will understand. Okay, next class when you join you will understand what I'm talking. Okay, so today we will just talk about perceptron. So you understood the architecture, what we discussed so far. In 1950 we found architecture called perceptron by Rosenblatt, right? And it is very, very old, perceptron, right? This is called the first neural network or the single layer neural network. We are not using perceptron anywhere today, but it is just the starting point. That's why we are learning. And this is called single layer perceptron, single layer neural network. This is the starting, you can say. This is the starting. And before that, if you want to understand from where this model came, it came from XOR concept, XOR. So gates, if you have learned about gates, from that, I think they thought about this architecture in 1950. This is called single layer neural network or perceptron. Now, again, why human think about anything, such things, right? They thought about themselves and it is very much inspired by our own neurons. So they try to understand, okay, we are processing information and through our ear and everywhere, we are taking information to our brain. What is there in brain, how we are able to process those information. And they found in our brain, there is something called a neuron. So neurons are there in our brain. What is there in the brain? Neurons. And this is a typical neuron architecture. This is a human neuron architecture. And what is there in neuron? Basically, there are three different things in basically in a neuron, right? So the first thing is input. We call it dendrites. And then there is an output. This is called action. And in between something is happening, right? Passing of information. So input can be different thing. You can see this is one input, right? So the input can be different. And then there is something happening, some processing is happening once the input is coming. And then there is output. Output also can be mostly one or multiple. You can see Y1, Y2. So there are multiple inputs coming in, something is happening, some processing is happening inside the neuron. And then there are multiple output going on, right? Like coming out. So that is the complete architecture. And from there, from this architecture, the thought of this architecture, and this is called a perceptron. Perceptron is very much inspired. So basically human are trying to copy themselves. So whole goal of AI is, and you will see like in next 10, 20, 30, 40 years, when your kids will be like at your age and you will be older, like 60, 70, 80 years, you will see they are in a world where computers are as intelligent as humans. Maybe they might not be so intelligent emotionally, but processing wise, right? Logically or reasoning wise, they might be equally important. Or the scary thing can also happen. They can be more intelligent also than average human. They say AI machines will replace average human because they can get the intelligence of an average human, not genius, but average. But what I'm trying to tell you is, yes, emotional intelligence is something which is with us, but the processing, the mathematical intelligence or logical or reasoning intelligence, we can reach to that level, and that is called AGI. And the whole objective is understand ourselves and replicate. The same intelligence can we pass. And this is a correct example. So perceptron came from human brain neuron architecture. In neuron, we have actions, multiple inputs. Something is happening, obviously some processing is happening, and then a lot of outputs. And based on that, you're taking actions. Similarly, perceptron, we have different input, something is happening, and then we have output. Okay, now you understand this architecture. Now let us go deeper inside it. Again, if I have to tell, this entire perceptron is a linear model. As I said, this is not the model that we are using today. This is just there in the history so that we are learning it. We are in a very, very advanced stage. We are using really complex models, but linear model can handle only linear problem. So perceptron has a limitation. It cannot handle non-linearity. But in today's deep learning models can handle anything. We will reach there maybe in the next weekend. Let us start with linear model. Again, this is inspired by, as I said, XOR gates or basically human brain. So what exactly a perceptron is? Perceptron is a linear function. Mathematically, if I have to explain, perceptron is a linear function, right? And what is that linear function? Y is a function of X, right? Y is a function of X. And you are trying to understand how exactly this Y and X are related. How I can find Y given X. That is the whole objective. You can only solve a category of problem, and that is called supervised. Before even I jump here, I forgot, I need to tell you one more very important thing, which is related to AI. That is called, in AI, any problem that you're solving, it can be in three categories, any of the three categories. The first category of problem that we solve in AI is called supervised, right? Now, how you're solving is up to you. You can use machine learning, or you can use deep learning, or you can use both and take the best, right? But you can solve supervised problem. This is the first category. The second category of problem that we solve is called unsupervised. The first category is supervised. The second category is unsupervised. And the third category is semi-supervised. Means it's a combination of supervised and unsupervised. The third is semi-supervised. Now, what is semi-supervised? I'll give you some example. You must have heard reinforcement learning. Have you heard about this? Anyone? Reinforcement learning? I think the keyword, at least, if you have heard about, that is a kind of semi-supervised. If you have heard about classification, regression algorithms like linear regression, or what we are learning right now is a perceptron. These all are coming under supervised. And there are a lot of algorithms in deep learning like encoder, decoder. which can solve unsupervised problem. Let me repeat what we have seen so far. We understood in AI, if I have to solve any AI problem, can be of three types, that is supervised, unsupervised, or semi-supervised. Currently, we are starting with one category called supervised. So let us park the other categories for later understanding. I'll explain about other categories later. But in supervised, again, we have basically what is the objective of supervised. The objective of supervised is very, very simple in mathematical way. Given X, find Y. This is as simple as that. What is supervised? Supervised is given X, find Y. That is supervised. So if you're solving this kind of problem, given X, find Y, you are in supervised section. Now you can ask me how I can find it. Given X, how I can find it. I'll give you a very simple example how your brain will work. Exactly the machine also will understand in that way. Let's say X is 2, Y is 4, X is 3, Y is 6. Can you tell X is 4, what is Y? What is Y? Unmute and speak. X is 2, Y is 4.
8, 8, 8.
8. Why you are saying 8?
Because
What
of same ratio maintaining.
What is that ratio?
Because
2.
of the pattern.
What is that pattern?
2 times 2
Exactly.
2 times 2x.
Yes. So
Y
this
is equal to 2x.
Yes,
Yeah.
and that is supervised. So what is happening is this is called historical data, and your brain took this data, it has processed, it understood the pattern. The pattern is okay. In this data, what is happening is each time X is 1 unit, Y is 2 unit or 2X. This is a relationship. Each unit in X is equivalent to 2 unit in Y. So the relationship is Y is equals to 2X. Now, if you know this pattern from the historical data, if my question is, can you predict given any X, can you find Y? Yes or no? If you understand this pattern, one unit is 2 unit, 1 is to 2. The ratio is 1 is to 2, or 1 unit change in X is leading to 2 unit change in Y. If you know this pattern, tell me, for any X, can you find out Y or not? Yes or no? Yes, obviously, yes. That is the whole story of supervised. Now, it's so simple for you because you are a human, you can process. It is not simple for the machine. What we're trying to do is every data that we get, that is called historical data. These are already happened. This pattern already happened. And this pattern will have X and Y, both information. Like I have given you 2, 4, 3, 6. It is called supervised because you are training the machine with input and output, both. You're giving examples of input and output. You know what? If X equals to 2, and you're not telling the relationship, you're not telling, okay, you know, Y equals to 2X. No, the machine will find this from the data that you are giving. Exactly like you all machines. Let's say, consider your brain is a machine. Your brain identified this pattern. Exactly same thing machine will do. What you need to provide? You need to provide lot many data. Like it's not like 1, 2, 3, 4 rows, millions of billions of petabytes of data people provide to the machine, and the machine understand the pattern from the data. And the data that we provide should have both examples like input and output. So I will tell, you know what? This is 2, then the Y is 4. When X is 3, Y is 6. When X is 4, then Y is, let's say, 8. When X is 5, Y is 10. Like this, if I just give 1 million example, the machine will try to understand the pattern from this data. So this is called model training. So what do you mean by model training? Model training means you give both X and Y to the model. The model will understand the exact relationship or the relationship between Y and X. That is called model training. So that in future, if you just give X, the model can predict Y because it knows the pattern from the historical data. Now, my question to everyone is, if I give you garbage, let's say if I give you 2 is equals to 4, 3 is equals to 10, 4 is equals to 25. Now tell me 5 is equals to what? Think, can you tell? Can you
No.
tell in this case? No. Why? Because the model, your brain is same, your processing style is same, your understanding is same. But in this case, you cannot identify pattern, or maybe whatever you are writing, let's say you just guessed something, or you have given, because the model will give you some output. The output accuracy depends on the input. That is so important. And non-technical people, they don't understand that. So the output accuracy depends on input. And this clarity you will have if you understand the maths behind the scene. Because if you give garbage, you will not find any pattern. Please understand. Before even jumping into modeling, we check data quality, what kind of data we are having, right? It's so important. If you give garbage like here, there is no pattern. Like you will see, let's say you are telling, looking at this too, maybe you're telling 2x plus 3 or something. This will not work because in the historical data, data is random. Do you see anywhere y is related to x? Do you think y is related to x here? No, it is not there. Y is not related to x. And you're forcefully trying to find out pattern, and which is whatever pattern you are getting, it's not correct because in the historical data, it does not exist. It's not like always all the model will give you good result. Is it clear to everyone? When the model will give you good result? If there are patterns. And if that pattern is repeating in future, if the pattern or the data is completely changed, then also it will not work. I'll give you one example. Let's say 2020, till that you have trained your model and you have predicted for 2021 sales. Do you think 2021 sales will work? No. Why? The data itself is changed because of COVID. So 2020, till that something was happening. Let's say your sales was continuously 2-3%. But in 2021, your sales, you have predicted same because that happened in the past. Let's say it is, let's say 2% you have predicted, but it might be like minus 20%. And this is not your fault, not the model's fault. It is because of the data. So who plays a great role? Tell me. A good model needs good data. And that's the reason all the GPTs that you are looking, even if you, me, anyone in this world, once they know the transformer architecture, can create exact same replica of GPTs or maybe GPT 3, 4, still your model might not be good. Why? You can replicate the maths, you can replicate the architecture, but what about the data? Data is different, right? So what data I am feeding, it's very important as compared to what data you are feeding. So what is important in today's world? Tell me, maths or data? What is important? Maths is
Data.
there with everyone. Data is
Data.
not.
Data.
Data.
Right?
Data.
Data is
Data is
important.
important.
This is a very good example. 2436, 24310. If you just collect every garbage and fit to your GPT model, it will not work, even though you will be surprised. Okay, I am using the same transformer. They are also using the same transformer. I have the same GPU, same architecture, because it is open. It is not hidden, right? The architecture is open. Everyone can replicate it. Still, we are not able to reach there because of the data. We are not having, that is, the war is about data right now. Because machines anybody can afford, right? They can have GPUs and all. But yeah.
ma'am, in real time, there won't be any pattern observed in many of the things.
No. Why you think that? There are patterns. And if it is not, then obviously data model will not be good. But there are patterns in everything that you see. There will be some pattern. For example, let's take...
Like ma'am, example, World Cup winning. There is no pattern in who will win the World Cup.
No, I'm just... Oh, yeah, that's correct. So it depends on the data, as I said. I think the algorithm is the algorithm. Once you have that, it's a very fixed structure. Yes, you can increase or decrease the layers and you can make it complex. You will do hyperparameter tuning. You will do lot many things that will not impact much. If you have quality data, let's say somebody has very, very, very efficient data, what they can build in a very small model with very good accuracy. Somebody can have a very complex model with garbage data. They cannot build a good model. So for me, I think, yes, algorithm is very important, but it's just a very small part. Very important part is data. And ultimately what we're trying to find out, yes, you're correct, Bikram. So if there is no pattern in the data, how hard I try, I cannot find it out. I'm searching a pattern which does not exist in the data. It's all random. So, and that also can happen, right? That's why need to be very careful, right? Okay. You understood what is supervised. What is supervised in a very similar, like if somebody is giving you X and telling you to predict Y, that is supervised, as simple as that. Within fraction of second, you can identify it. Now you need to look at some, like in supervised, we have two sections. How many sections? Two sections. So one is classification and one is regression, right? In supervised, we have two sections. One is regression and one is classification. So what is this regression and what is this classification? It is all same thing, but you check your Y. If Y is a number, right? Then that is regression. If Y is a class, then that is your classification. What is supervised? Given X, predict Y. Now, what is Y? What is the nature of Y? Let's say you're predicting sales. Can you guess what is this kind of problem? Regression or classification? Regression, because it is, let's say, 1,000 or 2,000. This is a continuous number. Or you're predicting house price. Or you're predicting, let's say, probability of winning. All these are numbers and this is continuous. So these are regression problem. Let's say you're predicting whether your credit card transaction is a fraud transaction or not fraud transaction. Fraud or not fraud. That is a classification problem. You have seen your Gmail account, everyone. Google is automatically doing a classification problem or applying a classification algorithm on your Gmail or emails, which can filter spam and inbox, spam or ham, right? And you are not doing it. If you open your spam, everything is done by Google. And that is an example of classification. So text data, you are classifying not only number, you can classify text, you can classify images, and spam or inbox. This is what you're predicting. Given any input, let's say the text, you're predicting whether the text will be going to spam or inbox. So you have two class. Now weather prediction, what is that? Classification or regression? You're predicting the weather for tomorrow given all the inputs.
Classification only.
Classification. So fraud detection, spam, ham. Image prediction, let's say a car or a bus or a truck or a motorcycle. Image classification. So any supervised can be either regression or a classification. Only by looking at Y, you can decide, right? Okay, so this is the background before we even start. So what you understood, AI has three different sections: supervised, unsupervised, and semi-supervised. Semi-supervised, we will skip. Unsupervised, we will discuss later. Supervised, we are focusing right now. What is supervised? Supervised is somebody will give you historical data, lot of historical data, where X and Y both is present. And you are trying to understand the relationship between X and Y using maths. You can understand that relationship using either using ML or DL. But the objective is you understand the relationship between X and Y and assume that the same relationship will preserve in the future data. So in the future data, somebody is giving you X. Already you know how Y can be related to X. So you can predict Y given X. That is the whole problem statement. Now how we can achieve it, right? Let's talk about very simple example. So we have this architecture called perceptron. I will just take one example, one X and one Y, and later I will add multiple X. Let's say X and Y, same example, 2 and 4, 3 and 6, 4 and 8, and so on. If I have to solve it using a perceptron, how will be my architecture? So there will be input and there will be output. There is nothing in between, as you understand. So input is there and output is there. Multiple input, multiple output, but we are starting with one input and one output. So I will write one circle here, and this is called my input layer. Why one circle? Because I have only one column. If I have multiple X, I would have multiple circles, but I have just one circle because I have one X. And then I have output. Output also I have one. So one circle in the output. And something is happening in between. So there is a link input to output. and some processing is happening here. What is that processing? We will discuss about this very soon, right? Let's talk about the first row. So I am just writing here 2. I'm just taking the first row, okay? I'm writing here 2, and this is called link. From output to from output to input, I have this link. Every line that you see will have 2 parameters. One is W and one is B, right? One is W and one is B. And this concept come from a linear model concept. So we will discuss that later. So let us understand like 1W and 1B. And what is the equation? How we are predicting? So the equation is to predict what is your Y. It is using a concept called linear modeling. And this is nothing but mx plus b. Remember what is this equation? Very popular equation. Anybody remember what is this equation? Mx plus b is the equation of?
Straight line equation, ma'am.
Straight line equation. So I'll tell about little bit, though it is not related here, but I'll tell about little bit. So what is the objective here is in linear modeling, the relationship between x and y should be linear. And let's say this is the linear means what? When you plot x and y, you will see a pattern. It can be a straight line or very close to a straight line pattern. See, it is just a hypothetical situation. In real time, it is not exact match, right? Sometimes there will be variation. Instead of 10, it is 11. And this is plus 1 is a noise. So what I'm saying is when you plot, you will find some pattern, like a kind of upward trend or downward trend you will see. And what we're trying to understand is we're trying to find a straight line among all of these points, which are as close as possible. So that's the concept of straight line. If you don't understand what I'm talking here, just ignore and focus what I'm saying here. So remember, in neural network, every link will have 1W and 1B. Every link will have 1W and 1B. And the equation is, if I have to write it, Wx plus B. How I am predicting y hat? Wx plus B. My question to you is, do you know what is the value of W and B? You know the value of x, that is 2. Do you know what is the value of W and B? You don't know. You guess. Maybe you can take, this is step number 1. Let's say this is step number 1. You don't have any idea. Let's take W equals to 1 and B equals to 2. Can you predict y now? Anyone? What is y? 1 into 2 plus 2. What is y? 4. Okay, I actually exactly matched. Let's take some random. Let's say 2, 2. So 2 into 2 into 4. So how much is the value? What is the y value?
6.
6. And it will be very, very, very odd because you have taken guess. So it might not match anywhere near to the actual value. Let's say it is 6 or 16 or 30 or 50, any value. Doesn't matter. So this is a step number 1. This is the prediction value. And now what is the actual value? Tell me, what is the actual value? In the first row, what is the actual value of y? 4. Now tell me how good you are in predicting, how to decide the error. Can you let me understand how to calculate the error here? What is the error? Whatever you have predicted and how much it is matching with the actual. So what is the error? Tell me, the error is
2.
6 minus 4 is equals to 2. Now tell me, what would have been the best case? What would have been the best case? 0?
Error is 0, yeah.
Right? And that is the goal. So we are starting from somewhere and eventually we are trying to update W's and B's in every step such that we will find that W and B which will give us the best value. In the sense, error will become 0. Can you guess what is the best value of W and B here? If I say W is equals to 1 and B equals to 2, this is the best value. Do you all agree? Why? Because if I just use W equals to 1 and B equals to 2, I will get somewhere around 4, which is exact match, means error equals to 0. But again, there is a trick. There is a trick. I'll tell you what is the trick. We are just in the first row. We have to repeat this process for the whole row. And the objective is not to minimize individual error, to minimize the whole average of all the errors. So I'll go one by one step. Let me just delete everything and just start from scratch. So what you're doing is you have X, you have Y, you have 2, 4, and then 3, 6, and then 4, 8. What is the question? Question is, given this historical data, can you find the relationship between Y and X? Y is equals to what X? That can you find Y equals Y and X relationship? That is the objective. To solve this, what you're trying to do is you are creating a perceptron network. So in perceptron, we have one input and one output. And this is X and this is Y. For every row, we are doing this. Row number 1, from input to output, we have one link. We call it W and B. We don't know the value. So for the step number 1, this is step number 1. Okay. Let me change the color so that you will understand. This is step number 1. What I'm doing in step number 1. For row number 1, 2, I am using, let's say in step number 1, I am using W is equals to 2 and B is equals to 2. And I am predicting here Y prediction is equals to 6. Y original is equals to 4. So error in step number 1 is 2. Now I'm going to step row number 2. Can you tell what is row number 2? What is the value? 3. And I'm using the same W's and B's like 2 and 2. And then can you tell what I'm predicting here? If I take 2 and 2, 3 into 2 plus 2, what I'm predicting? 6 plus 2, 8. So I'm predicting in the second row 8. So what is the error? I'm predicting 8. The original is 6. The error is 2. In the third step, I'm taking again 4. Again, I'm doing this 2, 2. And I'm predicting in the third step or third row. What I'm predicting? I'm predicting somewhere around 10. And the error equals to 2. Can you tell what is the average error? Average error is sum of all of these errors. So what is the average error?
2 only, 2 only.
Right? 2 plus 2 plus 2 divided by 3. For 3 rows, if I have n rows, it will be divided by n. And the objective is minimizing this average error such that this will be equals to what? 0. Right? So that is the whole problem statement. There is a little tricky thing here. Here the things are all rosy because it's a dummy data, but in real time, sometime you will predict more, sometime you will predict less. So the error, sometime it will be minus, sometime it will be plus. And if you just take just the average, what will happen? Plus minus will cancel. So what is the solution? Instead of just taking the errors, you take square of errors. Why we are taking square of errors? Is it clear, everyone? Why
Yeah, removing the negative, man.
Yes, we are taking square of errors just to remove the positive and negatives, right? I don't know why it is coming and how it will go, the top names.
Is it to get an absolute value?
Yes, to get an absolute value, but we are squaring it instead of taking absolute. I'll tell about that in a very short time why, but can I write in mathematical term? Can I write the error function is nothing but I is equals to 1 to n wi xi plus bi. And yeah, so this is just the y and sorry, not this one. Let me just, this is the y that I'm predicting, right? Okay, error square is nothing but this minus y. I will just talk about that in a short time, but how to erase this? Is there eraser? Yes. I'll come to this point later, right? Let us first understand. Okay, so this is something which you understood. Now, this is step number 1. My question to you is, in step number 2, do you have any idea what to do? In step number 1, the error is not 0, right? It is coming 2. So you have to go till the steps where error equals to 0. You need to repeat until you reach to the point when error equals to 0. In the step number 2, what you can do is you try to give W's and B's some different value and try. My question to you is, do you have any idea what value you should keep for W's and B's? Do you know what you should take W's and B's? Like 2, 2 initially you have guessed. In the step number 2, you again guessed, let's say W equals to 3 and B equals to 3. And you have repeated for step number, for first row you have calculated error, second row you have calculated error, third row you have calculated error, fourth row you have calculated error. And then final error is, let's say it was 2, but in this step when you have taken 3, 3, the error is 4. Tell me, do you have done a good job or bad job? Taking 3, 3. It's
Bad
better or
Bad job.
worse? Bad job, right? Like 2 to 4, the error increased. So error should reduce to 0. It is increased. Means whatever values you have taken for W's and B's are not correct. You are going in wrong direction. Again, in step number 3, what you will do is you will guess. Maybe W's you will take, let's say you reduced maybe to 1 and B you have increased to 4. And you have, like, let's say you got the error somewhere around 1. So my question to you is, do you think by just guessing the W's and B's, you will ever reach to a point where you can find the values of W's and B's which can give you 0? Is it possible?
No.
No, because you will just shuffle, right? Sometime it will go up. In some iteration, it will go down. Again, it will go up, go down, go. There is no guarantee that always it will be reducing. The ideal situation is every time you train, your error should be less, 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 and less. To a point where it is 0, you need to stop. But here it is not at all kind of constant. You will get a graph like this. And if you are lucky, you may get, but otherwise, most of the time, it is an infinite loop. So these are epochs or steps, step 1, step 1, step 2, step 3. And this is nothing but, let's say, error. The ideal situation is every step you go, error should be reducing, reducing, reducing. And you need to stop at that step where error equals to 0. But what will happen in this guess approach is sometime it will go down, sometime it will go up, sometime it will go down, up, up. So you will never reach. You will just randomly, you will here and there, you will just move. That's the reason we need math. We cannot use guess approach and we need math which can help us to find the values of W's and B's, which will help us to go to the place or find the best value of W and B, which can give us error equals to 0. So what is the objective of whole story? The objective of whole story is getting W's and B's, and these are parameters. Have you heard about the term parameters? Any model, 70 billion parameters, this many billions parameter. Have you heard this term before? Before coming to the class, you have heard this term, right?
Yeah,
And
with
what they're
ChatGPT and
talking
Llama.
about, yes, what they're talking about these W's and B's. And billions of parameter means definitely this is not the architecture. Their architecture is so complex. They have billions of W's and billions of B's to be optimized. That is the whole game of this deep learning, or basically this ANN architecture. You have bunch of networks. Every model is a linear model. Y is a function of X. And using some technique, you're trying to reduce the values of, or not reduce, optimize, sorry, not reduce. You're trying to optimize the values of W's and B's such that the error will be minimized. That is the whole story. And once you get this, your model is trained. And once you know that W's and B's, you know the exact relationship and you can predict Y. You know W, you know B, you know X, you can predict Y. So that is the whole game. We will go there in detail. So next class, when you join, I will talk about the complete architecture in detail. This is just a theory class, just an introduction class. So in detail, we will discuss in the next class. I will create a nice note for your batch. I will be just showing you the previous notes, but I'll be having a different note for your batch, right? So deep learning, you understood what is deep learning. So derivative, from here I will start in the next class. So you need to have some basic understanding about derivatives before we jump. I will talk about it maybe in the next class, but this is something how the human brain is, like dendrites, neuron, and action. And from this is the perceptron architecture. I have just explained you with one particular node. In real time, you may have multiple X. So this is your input. Input is equivalent to how many columns you have in your data. Let's say you're predicting house price, that is your Y. And to predict this house price, you are using square feet, which is your X1. You are using a number of city distance. Let's say this is your X2. How many rooms are there? Let's say this is X3. So given X1, X2, X3, you are predicting Y. So can you tell how many nodes will be there in the input? How many circles in the input layer? How many circles?
3
1 to
circles.
3.
3 circles. Correct. So we have this x1, we have this x2, you have this x3, and there will be one y, so one circle. Every x to y, there will be a link. Every link will have w's and b's. So in this case, can you tell how many w's and b's I need to optimize? 6. Why? Because every link will have one w and one b. Or basically you just write WB if you don't want to confuse yourself, but every link will have 2 parameters. Number of links into 2, those many parameters your model will have. If you have 10 parameters, you have 5 links, right? Every link will have one W and one B. Now, okay, you understood the architecture. Now, what is happening behind the scenes? So in between, it is just a simple linear model. So how you are basically predicting is you're just using the linear equation. So I can write this is W1, W2, W3, B1, B2, B3 can be written as B because it is anyway it is scalar quantity, right? So what I'm trying to tell you is, let's say there are 3 nodes. This is W1, B1, this is W2, B2, and this is, let's say, W3, B3. And this is, let's say, Y. So I can write W1x1 plus B1 plus W2x2 plus B2 plus W3x3 plus B3 is equals to Y, right? So B1, B2, B3 is constant. So I can just write B here. So I can write all of this thing in terms of equation, which is nothing but I is equals to 1, 2, 3 Wi xi plus bi. Can I write this? Is it correct or not? This to this? Everyone understood? Can I write
Yes.
this? So what I'm doing here is basically to predict y, I am just using a very simple equation, wixi plus bi. So don't worry about this phi, we will discuss that later. So what is there in between? So there are some input node, there is an output node, and we are just using I is equals to 1 to n wixi plus bi. Using this, we are predicting y. That's it. This is as simple as that. Any doubt in this? Any doubt? Any question, any doubt? Just look at this and feel free to ask me. This is first class. I mean, this is complicated concepts. Anywhere you have any doubt, is it clear?
Yes, madam. Yeah, that is amazing actually. Yeah.
Yeah, it's nothing much. It's just a linear model. My question to you is, if your data is non-linear, can you solve this using this architecture? Yes or no? Non-linear means y is equals to 2x square. Basically, do you think a straight line will work? First of all, if you just think about, okay, let me give you. So if you plot, what do you mean by linear and non-linear relationship? Non-linear means what? Degree, not degree 1 equation, right? For example, y equals to 2x square. So what is the equation? Let's say x equals to 1, simple x square. What is y? Y equals to 1, x equals to 2. What is y? Y equals to 4, x equals to 3. What is y? 9, and so on. So if you plot, what you will get something like a curve, right? This is not exactly, but I'm just talking, let's say not a straight line. Let's say the data is something like this, right? So in this case, tell me what is a good optimization, or if I will tell you, you have all of these points, you need to find pattern from this point. Will you use a straight line to find pattern, or you will use a curve to find pattern? What is the best approximation?
No, straight line only, madam.
Straight line. Okay, how? See, this is the data. Tell me, there are 2 kind of pattern exist. This is your one type of pattern, and there is another kind of data, which is nothing but you have seen COVID webs. Let's say this is something like this, right? And I am just trying to find pattern. So I'm just giving all of this data, the normalization, or basically the pattern of all of this data is a straight line, which is the closest to all of this point. Thus, I'm trying to find this straight line, which is mx plus b. And here also I'm trying to find a straight line. To tell me in which case the straight line is very close to the points.
In first
Because
case.
first case, yes. In the second case, do you think a straight line is a good approximation or something else I need to use?
Something else we need to do, madam. Straight line, it won't work here.
Because it's a curve. Maybe I can use a curve here, right? Are you getting? So instead of straight line, maybe if I try to find a curve which is most closest to all the points, it will work. So what I'm trying to tell you is this particular is completely linear. Do you all agree? This cannot solve non-linear problem.
Yeah,
If,
yes, madam.
Yes, ma'am.
if X and Y, so this kind of thing you cannot pass here. Only this kind of thing, right? Where there is a relationship which is degree 1. This can be solved using this. Non-linear problem you cannot solve using perceptron model. Okay, so there are many things we need to understand. When you connect in the next class, I will talk about, so the real neural network is something like this, which is super complex. We have a lot of in-between layers, and the neural network, actual neural network can handle linear data, non-linear data, anything. That is because of hidden layers. We will talk about it in the next class. When you join, today is just an introduction class. We'll talk about the complete math, how to get your W's and B's. Today, I just gave you some hint. If you don't understand also, that is absolutely fine. In the next class, you will understand 100%. So W's and B's, obviously guess will not work. So there is an approach, we called it gradient descent. This is the method to optimize your W's and B's. And the output of that is this. Using this formula, actually, we need to update our W's and B's, not randomly. How we got this formula is a different story, which will take 30 minutes at least to explain. But just if I take this formula as it is and try to again optimize my model, so what will happen is this is step number 1. What you are trying to do is you have taken some W's and some B's, random guess, 2 and 2. And let's say you average error you found is 2. And now what you have done is in the next step, to find your new W's and new B's, you're not randomly using it. You are just using the formula, which is old W minus error, whatever you are getting, into X into a constant called learning rate. So what is your old W? Old W that you have taken is 2 minus the average error that you got is 2 multiplied by X value in that particular row. Let's say it is 2. Learning rate is, let's say, 0.001. It's just a constant. You can change it. And whatever you found, let's say you are getting 1.6. This is your new W. And how to get your new B? Same, old B, which is 2 minus error is, let's say, 2 into learning rate, 0.001. And let's say the new B is 1.2. And that what you're trying to do here is, this is your network. You are just using some W's and B's. This is called feed forward. You're using these W's and B's and predicting. You have actual. You are finding error. And then once you find the error, you are getting the new values of W's and B's. You are back propagating, going back and updating the values of W's and B's using this formula. This is one step. This is step number 1. And you are doing it for all the rows, right? So one step means all the rows you have feed forward, find the error for every row, taken the average of that error, use this approach, back propagated and updated the new W's and B's. Now in step number 2, what you will do is you will take the W's and B's that you have updated in the previous step and you will again repeat, you will find the error, right? Again, you will get your new W's and new B's using the formula. This is called feed forward and back propagate. In step number 3, you will take the values from step number 2, updated values from step number 2, you will predict, update and repeat. And when you will stop, tell me in this equation, when you will stop updating your W's and B's? When you will stop? When error equals to 0? Tell me, when error equals to 0, your new equals to same as old, isn't it? When error equals to 0, you will stop or not? Will you update further? No. And you will keep repeating until error equals to 0. Every step like this, you will repeat. I know you could not understand 100%. That is absolutely fine because you don't know the background. Today's whole agenda was to explain you perceptron. We have not gone to neural network yet. In the next class, we will discuss about neural network in detail. But at least the first note, is it clear? Is this architecture is clear? Leave about the second one, but is this architecture is clear? This is clear. The whole agenda is to make sure you are understanding this. Is it clear, everyone?
Yeah, yes,
Yes, ma'am.
madam.
Yes, ma'am.
So From here, we went to fully connected, and from fully connected, we have other architecture coming up. Next class, when you join, what we will do is I will create a nice OneNote for you and I will share it with you. I will collect it from different blocks, different nice visualization, my own handwriting, and I will use that note. This note I have created long back. And that is the beauty, because deep learning, machine learning, maths, once you have understood it, it is not going to change overnight. That is the best thing about AI, right? Yes, tools will change, but technology, like the concepts, will remain as it is. And few recent developments are happening. You can upgrade quickly. What I'm trying to tell you is it is difficult to learn, but once you have learned, it will remain with you forever. It is not going to change overnight. So you have seen 1950, this model has been created. And after 66 or 70 years, we are learning it. Are you getting? So the technology tools can change, but the concepts, the maths, the algorithms will not change overnight, right? New things can be added, but the old things, if you understand new things quickly, you can upgrade. So learn it once and it will be helpful for your whole life. That's what I'm trying to tell you. You learn it once, don't give up. Many people, they give up thinking, oh, deep learning is very difficult and all that. But trust me, if you don't know deep learning, you should not be learning generative AI at all. Just learning generative AI at high level, it will not take you far away. You cannot reach far distance. Maybe few toy model you can create, but real-time enterprise solution you cannot build. And you cannot get job only, because every job interview, they will ask you 80% of the questions will be from deep learning. Maybe 20% is on the tool. They will not even ask many questions from the tools. Tools are needed in the real time, but in the interview, theory is needed, very, very deep. And they're asking a lot of things, like what is the difference between bot model and GPT model? What is the difference between encoder and decoder? What do you mean by transformer? What is the good thing happened? So every theory, everything, tit by tit, they're asking. So if you are good at theories, I think 80%. So they're checking whether you directly jumped into generative AI without understanding anything, or you have some background. That's what they want to check, right? Okay, so this is all about the whole story. And I'll just give you one last update, right? So what do you mean by your pre-trained model? Pre-trained model means these W's and B's are already known, right? So if I will tell you, you know what? You have your own X, W is 2, B is 1. How much time it will take for you to predict Y? Fraction of second, right? But if I will not tell you W's and B's, you have to spend some days to get the W's and B's. Yes or no? You have to train your model, na, step by step, step by step. Then after certain time, after certain epoch, you will get your W's and B's. That is all about generative AI. So what they have done is, what about general intelligence? You take everything available on internet, right? Every data available in internet. You take everything. They're telling like that, but what data they're using, God knows, right? But anyway, so they're feeding all the data, massive data, everything that is present in the internet. Actually, there are laws. You cannot use every data. It is available publicly for everyone, right? There are certain sites, there are certain, I'll talk about it maybe in the Gen AI class, but if you want to create your own LLM today and you want to get data, there are certain sites, there are certain publicly available data you can use to train your model. Having said that, data like, let's say, personal websites, you cannot crawl. There are certain legal entities to it. Companies are following or not, that is a different thing, but you cannot simply take everyone's. Let's say Facebook, let's say Facebook is generating any LLM model. They have data. Every data is available, right? Like the customer's data. They cannot use that data. It is illegal. They can only use publicly acceptable data. They cannot use confidential or customers' data or client data or stakeholders' data or anyone's images or personal details. They should not use those. That's the reason people are moving towards open source rather than monopoly or central. It should be decentralized. Because when a company is owing the model, it is owing your data, right? And it is okay to get a good model, but at what cost, right? it should not be like, I mean, if anything happening, any data leak happens or something, the company's entire information will be public. And that is more dangerous than this outputs that we are getting. So basically, you need to understand a lot of things when we are building a Gen AI model. Security, privacy, lot of things you need to understand, right? All of these things you can relate if you know how the models are created, first of all. And that's the reason these theories are very, very important. Quick summary what we have understood. Number one, we understood today that the AI journey is not happened recently. It is like since centuries, like 70, 80 years before that, like 1950s. Around that time it started. And the first thing that started in deep learning world is called perceptron, which we are learning today, around 1950 by Rosenwald, right? And after that, lot many things happened. People started inventing new algorithms in machine learning, try to solve a lot of problems using machine learning. And deep learning was not popular because of certain problems. But in 2007 to 10, or maybe 7 to 14, I will say, during that 7-8 years of window, lot many things happen in the deep learning space. Hinton, who is known as father of deep learning, he has given solution for the problems, and lot many other scientists also. And for that reason, after 2014, you have seen rapid development happening in deep learning. And transformer is again a groundbreaking. It is 2017 by Google. Attention mechanism has been invented, and because of that, the model can remember long context, and that is a game changer. If you remember long context, like a human, so we are human because we understand, we can process. See, somebody has told me a paragraph. I cannot just remember the last word or the last sentence. I understand the context of the whole paragraph, and then I try to answer, right? That was the problem. So the models were not able to capture long context. That is very essential. So when you are just predicting the code, you need to understand the code from starting to ending. Then only you can generate the code for the next block. Exactly same. So that concept is called attention, and it has been invented. Long context now the model can understand. And after that, it is just going on and on in the forward direction. GPT-1, GPT-2, and then GPT-3, GPT-4, and GPT is just one kind of model, but we have lot many other different kind of models which has been started. And where we are leading towards a space where it will be more logically and reasoning wise, it will be more intelligent. That is the goal, right? If you're asking me what is the next goal, more logical. Can we make the machine more logical and more reasoning based so that it can solve complex problems like how our human brain can understand, right? Okay, so this is the architecture of perceptron, which is a linear model. Input and output, nothing much. Output is a function of input, and that function is wi xi plus bi. And w's and b's are called parameters, right? Okay, so let us connect on next weekend and we will continue with our neural network. So it's a very interesting weekend. What we will do is Saturday, we will understand the complete architecture of neural network end to end. Sunday, we will understand one project end to end. I will talk about the deep learning life cycle, like what all steps you need to follow, and using TensorFlow. The library of deep learning is called TensorFlow Keras and PyTorch. So first we are using TensorFlow, and then we might use PyTorch also. So using TensorFlow, we will build our first deep learning artificial neural network end to end on a sentiment analysis project. So we'll take text data and we will build a sentiment analysis on top of it using deep learning architecture. Right. That is the takeaway for next weekend. And you have any question, you can reach out to me. Right. And I'll solve it maybe.
I
Okay.
have
So
a
based on
question.
this, yeah.
For example, if I'm predicting and I have the context of the prompt, like how are, and the next word is what I'm predicting. So that means I'm calling on how are acting as an input, right? That is X, and I'm calling the LLM. And then when LLM is called, it is applying that y is equal to mx plus b, and then
No, no,
applying
no, no, no. We are not even using this. This is just the starting point, but this
right.
is the end point for everything. So this is one of the model. Remember, I told you inside neural network, we have deep learning. Inside deep learning, what we have? Generative models, right? So we are
Mhm.
in generative models to create like what we are using. The transformer is a kind of generative model. This is not a generative model. Rather, this is, I will say, it's a neural network concept. So basic architecture. Directly, we are not jumping into transformer. We are going step by step. We are just learning the perceptron, and then we are learning the fully connected network, and then we will learn the transformer. So once you understand the transformer architecture, you will understand how it is predicting the next word. To predict the
Okay,
next
okay.
word, you need to understand transformer. Okay,
But
not this. This
okay.
is okay. This is
Uh-huh.
again the basic building block. This is used everywhere, but not only this. Along with this, we need extra layers. We call it transformer. And to make you understand the transformer architecture, it will take around 1 or 2 hours. And this is the architecture of transformer. If you just go and type transformer in Google, you will see the complete architecture. It's very
Okay.
complex.
But this
And
prediction I'm talking about is different than what you have explained. I mean, this is predicting
yes,
y, but like on a linear. But what I'm giving an example is of a transformer, which is a different
yes,
algorithm.
exactly. So this is the architecture of a transformer. So we have an encoder and decoder. So you are giving your input, what is happening behind the scene, and then finally. So don't get scared looking at this in real time. Actually, you are not using at all. You're just writing 2-3 lines of API calls and done. But this is behind the scene. If you are interested, what is happening? And let's say tomorrow you want to build your own transformer, right? From scratch. Then this will help you. So I think we will do that in not even next week, next to next week, we will discuss this, right? This is used in GPTs. We will
The,
understand in detail, but this is very early class to
but
explain.
is the perceptron is the like a base model or the foundation model, which is like
Nothing.
in
Perceptron is just in
transformer.
1950. It's an old model. It's a single layer. We are not even using it anywhere. This is
Okay,
just
okay, and
starting point. That's why we are learning.
okay, and transformer is not built on the perceptron.
No, no. It's a multi-layer.
Okay.
Perceptron is single layer.
Oh, but okay, it is. But layers are added, but the concept is the same, though.
Concept is also a little bit different. I will talk about this is a completely different model. As I say, it's a generative
Okay.
model. It's a
Okay.
different algorithm, right? We'll discuss about that later. But why we are learning ANN? Because ANN is there in every algorithm. So the output of every algorithm is fit to ANN. That is the last layer. So don't worry about other things. Don't ask me future questions. Just focus on what I'm currently, which module I am in. Just focus on that. Slowly, slowly, it will take time. In 2-3 weekends, you will understand the whole game. What is happening and why we are learning, what is important. Everything will be so clear to you. But we will go step by step. Today's topic is perceptron. Is it clear, everyone? And there is something called activation function, which I have skipped. Next week, I will explain about perceptron, and next week we will also discuss about complete architecture of ANN and implementation. I will also tell you how to integrate your system with GPU CUDA. So I think if you have GPU cards in your laptops, better to do it and record it, and then I will share it with you. It's very complex. In fact, if you just do some mistakes, you have to redo the whole process. So do it carefully. If you really want to, you might not need it now, but when we go to generative models for Llama, if you have a good machine like 16 or 32 GB with graphics cards, actually you can use lightweight models. And for that, I think if you have GPU, that will be great. So you can enable GPU. How to do that, I will explain through a video. I will record and I will share it with you. You need to do the same thing what I'm doing in my system. But it is Windows. For Mac, please refer to any other video. Right, because in my Mac, I think there is no graphics card. I think I really don't know, but here it is present. So I can record and I can share it with you. Okay, thank you everyone. Let us connect in next weekend. We'll continue from here. Okay, thank you everyone.
Okay,
Yeah,
thank you.
thanks.
Thank you.
Yeah, thank you.
Thank you.
Thank you.